Today, you are here with me to dive into the world of quantum mechanics. But I have a request for you. Do me a favor. Drop all your notions and common sense before entering it. It may seem silly, but it will help. Do away with all your concepts about time, space, and reality. As you will enter, reality will just be a joke. Let me give you an example. I am here, but I am quite there, and I am quite a little bit on the moon also at the same time. Yes, quantum mechanics allows it. Okay then? You okay? Let's dive into it. Let's start with the experiment that resides at the very heart of quantum mechanics. Let us firstly describe waves in water. At some distance, if we place a barrier with two narrow openings in it, it will stop most of the waves, and the wave that pass through the slits emerge as two new waves. When these interact, they will form this cool looking interference pattern. This is formed because when peak of one wave combine with peak of other wave, they add up, and when the peak of one wave combines with crest of another wave, they cancel it out. This is also seen when light passes through these narrow slits. But wait, we know that light is a wave in electromagnetic field, thanks to the work of James Clerk Maxwell, but as far as Einstein is concerned, we know that light comes in little indivisible packets called photon. Emphasis on indivisible. So now we know that photon is an indivisible bundle of waves. The interference pattern created by light can have a simple explanation. When two photons pass through each slit simultaneously, on the other side of the slit they will combine and form this cool looking pattern, isn't it? Okay, here comes the best part. If we shoot one photon at a time, then firstly we will see that it will land at random places. But if we keep sending one photon at a time for some time, we will start to see an interference pattern. Remember, light is an indivisible. It cannot divide and travel through both the slits. Then how will one photon know the most likely place where the previous photon landed and the future photon will land? This is not only the case with photons. Electrons, protons, sometimes atoms or whole molecules will show this behavior. It seems particle behaves mysteriously after it is shot and before it lands on screen. Like it is present at 2 points at the same time, and that two versions of the same particle interact with each other and influence how will they land on the screen. Frankly saying, we don't know what is happening in between. But we have some interpretations of the math that describes it. The most famous interpretation is Copenhagen interpretation. It says that particle exist as a wave of pure possibilities. That means a particle travels all possible paths, and those possibilities interact with each other to make some possibilities more possible and some possibilities less possible. This wave of possibility is called wave function, and describing a wave function is at the very heart of quantum mechanics. It also says that a particle will stay in its wave-like realm of possibility until it is observed, and when it is observed, its wave function will collapse. and we will find it at one place that happens on the screen. But you know why not only photon but electron, protons, and sometimes atoms or whole molecules show this behavior? The answer is these are not like particles or something. We call them quantum mechanical entities. And you know what? Everything is wave as described by Lee Broglie. But you know why I said that I may be present on the moon? That is because I am also a wave, and there is a very little chance that I am present on the moon at the same time until you observe me, and you will find me where I am most possible to be found, that is, here. If you think that this was weird, then wait until I arrive at many worlds interpretation, and at any time if you think this is not possible, remind yourself that we are not in regular world. We are at the very edge of reality.